right, guys, we're going to go ahead and get started. Thanks a lot for showing up to what is my very first defensive talk. So I'm putting my big boy pants on today. All right. So welcome to Living Off the Land 2, the defensive edition. I gave a similar talk, I believe it was 2 years ago, with an offensive spin with Chris Campbell. Is he here? Damn it. Anyway, I had a great time presenting with him, so sort of our motivation behind running with this theme was inspired by him. I also want to give another shout out to him. He served as a great mentor for me after I got out of the military and wanted to get into InfoSec, so he had the faith in me to succeed, and he served as a great mentor. So you know, everyone out here probably has one person like that served as a great mentor. So definitely try to give them shout outs as much as you can and acknowledge where you came from. So thank you, Chris. All right, so let's get started. A little bit about myself. I'm the manager of security research at Varus Group's Adaptive Threat Division. I've got two other people on my team, Will Schroeder and Casey Smith. I freaking love the people I work with. And then my extended family at ATD, we have some like amazingly bright people like this guy right here. I'm a Microsoft MVP, specializing in PowerShell. Jared and I, if you don't know, are huge PowerShell fanboys.
Yeah, I'm Jared Atkinson. I'm the defensive services lead or technical lead for the Adaptive Threat Division as well. So I focus mostly on continuous monitoring and compromise assessments for Adaptive Threat Division. Previously, I was in the Air Force for the Air Force Hunt Team for 5 years.
All right, so sort of what spawned the idea for doing this, aside from presenting the offensive edition of this a couple years ago, was at a former gig when I was working at Mandiant. We had been seeing more and more compromises where WMI was used as a vector. Primarily, it had been being used as a lateral spread method, but in previous talks, I had spoken about how APT29 have been using WMI very heavily for their operations, not just for lateral spread, but they also use WMI as like a covert storage mechanism where they store their payloads and also store the result of their payloads in the WMI repository. So, of course, me working at Mandiant, I was asked the question, how do we defend against this? How do we detect this? And so I put some thought into that, and that was sort of the genesis of like all the WMI talks that I gave last year, and we're going to cover some of those concepts as well today. It won't be the primary component of this talk, but it turns out WMI is great for detecting WMI attacks using WMI event subscriptions. So, you know, throw in your exhibit YoDog reference wherever you like, so it definitely applies here.
Yeah, so my interest in kind of living off the land from a defensive perspective kind of started in the Air Force. So the Air Force is just like any big organization. They have all this certification and accreditation, and you have change review boards and all these things. And so compiled code wasn't something like we couldn't just make a binary and say, hey, we're going to run this on every system in the enterprise. But we could run scripts on every system in the enterprise. And so, yeah, the cool thing about PowerShell is you can do the same things that you could do in compiled code. You could access the Win32 API, you could do all those kinds of things. And so it's kind of like Field of Dreams. If you script it, they would come. Like you could just, if you could write a PowerShell script to do it, you could run that thing anywhere you wanted and everybody was okay with it. So that kind of led me down the using PowerShell to do everything that I do. All right, so the agenda, we already kind of covered our motivation. We're going to talk kind of in like a phase methodology of kind of a defensive structure. So data collection, talk about a couple capabilities or built-in commands that you can use. Intrusion detection, investigations, and then Matt's going to go into kind of like hardening and using device guard, talking about device guard. All right, so for data collection, this is just kind of, we really try to focus kind of on like an endpoint data collection methodology. So gathering things like processes, services, network connections, auto runs, all the different persistent locations across every system in the enterprise, bringing it into something like Splunk or Logstash or whatever your SIM of choice is, and then trying to do some sort of analysis on that. So two really good ways to do this are using WMI. WMI has been around since Windows 95 at least, I think maybe possibly earlier. It's almost always available, assuming that there's not some firewall that's blocking the ports that you would need, and then which there typically isn't in my experience. And then one of the cons is that data is going to be limited to the available WMI classes. So WMI classes that are on Windows 95 there's less classes on Windows 95 than there are going to be on Windows 10, for example. And so using WMI, there are ways to kind of go outside of the WMI schema or like classes, but you would have to be pretty creative. So WMI is kind of limited in that sense. The other option is Windows Remote Management, or WinRM, which is the basis for PowerShell remoting. And so it's available since kind of Windows XP, and it unlocks PowerShell functionality. So this is basically anything you could do in .NET, you could do over Windows Remote Management, and anything in the Windows 32 API. So, all right, so kind of segueing from that, we wanted to kind of make a case for PowerShell remoting. So as a consultant, I go to numerous clients and try to ask them if they have Windows Remote Management enabled in their enterprise, and they say no. Why would we do that? Bad guys are going to use that, and it's going to be terrible, right? And so I don't agree with that, and I think like Lee Holmes and Jeffrey Snover are very big zealots for pushing out PowerShell remoting throughout your enterprise. And so some of the reasons that you would do that is because PowerShell remoting was built with security in mind, right? And so it's firewall friendly, so PowerShell remoting uses one port, 5985 for HTTP or 5986 for HTTPS. It's always encrypted, so don't let that HTTP versus HTTPS thing confuse you. PowerShell remoting is encrypted by default, and so if you're on the domain, it's always going to be encrypted regardless. It enables numerous valuable capabilities, which I'm going to talk about here in a second. So PowerShell remoting, you have things like inner PS session, which I'll demonstrate in a second, and you have things like invoke command, which allow you to run an arbitrary command on a remote system through PowerShell. You also have things like Windows event forwarding. So we have Windows event logs on every system. That's cool, but how do you centralize those event logs? Well, you can use Windows event forwarding, which runs over Windows Remote Management, to centralize all those event logs in one location. And then it provides an alternative to vulnerabilities of current admin protocols. Not saying that it's impossible to find a vulnerability in Windows Remote Management. I'm sure it is. There's none that I know of that are public at this point. But like the protocols that you're already using, like SMB, tons of vulnerabilities going back to Windows XP. You have like MSO 8067 is probably the most prolific vulnerability or exploit out there. And then you have like RDP. RDP, a lot of administrators use it, but it causes interactive logons, which expose your credentials to credential theft attacks like Mimikatz, as to where Windows Remote Management would not do that.
Yeah, so it uses the network logons.
Yeah, so network logons for Windows Remote Management. All right, so PowerShell remoting, going into invoke command, this is kind of that one-to-many remoting, and so it allows you to execute arbitrary code on a remote machine or machines. And so kind of the syntax for doing that would be invoke command dash computer name, computer1 in this case. Script block, anything within the curly braces in that case, so get process, is going to be run on that remote machine and returned back to you locally. And then you would supply credentials for the remote machine. Another really cool thing that not a lot of people know about, I just learned about it like 2 months ago, is you can actually, if you have a function that's, defined locally, you can actually run that remotely, kind of transparently, some magic. I think that starts in PowerShell version 3. Is that true? No. Probably 2. Okay, so yeah, so that functionality might even exist in PowerShell version 2. Back in the day when I first started using invoke command, one of the problems that we faced, or so we thought, was that you had to have the actual function defined on the remote system in order to call it. That is not the case, and if I would have known that 5 years ago, I would have saved myself a lot of time. So, yeah, and so I'll do a demo of that in a second. The other option is enter PS session. So a lot of folks use PS exec to kind of get a command shell on a remote system, and kind of do whatever they want to do with that command shell. The alternative is enter PS session, which runs over WinRM. It starts an interactive PowerShell session with a remote computer. And the syntax is enter PS session dash computer name, comp1 dash credential, and then you would pass it credentials, and it would prompt you for a password in this case. All right, All right, so kind of just doing a real simple session.
You guys see that at the back?
Where's the
By the way, you can actually move the mic up on the clip. It'll be a lot easier. You guys can stand up, call it.
like that?
Slide the mic
Oh,
up
yeah.
closer to
You're talking like that.
Yeah,
There we
like-
go.
like before.
Okay. Is that better? Good? Okay. Now it's getting some feedback. But all right, so we already have a PS session, which is basically an authenticated session with a remote system over WinRM already created, and so I'm just going to pass that session, and so then I could do script block. And we're just going to run get process against the remote system. Oh boy. Yeah, I know. Yeah. The sessions got disconnected while we were waiting, so let's just remote now. All right. So I'm a Mac user, and then when I switch over to Windows keyboard, it jacks me up. So, all right. Yeah. Yep. There we go. Okay. All right. So what I just did is I ran get process, which is a process listing in PowerShell. You'll notice that all the normal properties are returned from get process, but there's an additional property called PS computer name, which tells me that this information came from the IP address 10.0.0.2. This will be like a host name if you have DNS and all that kind of stuff set up. So just kind of a simplified example of us running a command against a remote system. All right, so the next thing I want to show, this is just kind of a cool thing. So we could do session. All right, PS session win10. So now I'm using enter PS session, which is going to give me an interactive prompt on a remote machine. You'll notice that my prompt in PowerShell changes to indicate that this is running on 10.0.0.2 IP address. And then I could just do, get process or whatever my command is going to be, and that's running on that remote machine. And then I could just type exit, and I'm back to my local machine. So just kind of a way to easily over WinRM get access to a remote system.
Okay, so now sometimes WinRM across the enterprise is not going to be an option. In that case, you could certainly fall back to WMI. Many of the same concepts of PS remoting in PowerShell version 3 and above also apply using these SIM commandlets. So when you hear SIM, just think WMI basically. I'm not going to distinguish between the two right now. But you can establish a SIM session instead of a PS session and get a lot of the same kind of functionality, and I'll show you some examples of that. So I've talked at great lengths about WMI in the past, so I don't want to belabor that per se, but WMI offers a great opportunity to perform data collection when performing like a hunt investigation. So, but the problem is, say like if you're sweeping for files or registry keys, it's a pain in the ass to form the WMI queries manually. Has anyone like had to deal with forming long WMI queries for stuff? We got a few guys, so you definitely know the pain. So I wrote SimSweep to kind of abstract a lot of that away to really help with incident response and hunt engagements. So a little bit more background about WMI. Again, great way to collect host information. The WMI service is listening on every system. So going back to like Windows 98 all the way up to Windows 10, Server 2016, that service is up and running. Depending on the OS, there's probably going to be like thousands of WMI classes available to you. So we're going to be doing demos against a Windows XP and a Windows 10 system to show you that the manageability is the same experience across all OSs when using WMI. Just there may be a different amounts or subset of WMI classes depending on the OS. There's a great PowerShell module for interacting with this stuff. The more classic commandlets were the WMI commandlets, which are available in V2. We're going to be showing everything in V3+, where the SIM commandlets were introduced. The great thing about those is that one, you can establish a session, so you basically only need to authenticate once. and then you can do a lot of queries thereafter. And it also works over multiple protocols. By default, the SIM commandlets work over WSMAN. So WinRM is a protocol that's built on top of WSMAN. So basically, if you have like WinRM enabled in your enterprise, then you can use the SIM commandlets using that default protocol. But you can also fall back to DCOM as the legacy protocol, which I'll be doing for Windows XP. So what's great is I can drive all this from PowerShell on a single system, and I don't even need PowerShell to be installed on the remote system to collect all this information. WMI is also extensible, so one of the downsides is you're limited to the WMI class library that's available to you. So like one thing that really irks me is like, yes, I can do a sweep of files really easily, but I can't get hashes of those files via WMI alone. So theoretically, you could extend the WMI schema, write your own WMI provider. This would be a binary that you would have to push down and like register that provider, but it is extensible if you really wanted to do that, if you wanted to stick with strictly WMI. It is possible. Again, queries can be very difficult to form manually, so I've tried to abstract a lot of that away. And also, DCOM is not the most firewall-friendly protocol. Fortunately, WinRM is. It's a single port that supports WMI operations, Windows Event Forwarding operations, and PowerShell Remoting. Okay, so SimSuite. Again, doesn't require PowerShell on the target, which is great. I love that. Operates on sim sessions, so you would have to call, if you want to do this remotely, you would call new-sim session to authenticate to whatever you're sweeping against. Authentication is performed once, abstracts away the complexities of WMI, and so it's comprised of sort of a core collection capability, so we can easily query, without having to form complicated WMI queries, registry keys, their values, the value types, and we can even recurse over the registry. Oh, oh yes. I didn't think this show existed. This is
It's not only warm, it's like hot.
Okay, so in addition to registry keys, we can do sweeps of the file system and recurse over that as well.
Great. You can change it all.
So I know you talked about registry keys and all that kind of stuff, but you can also do directory and file listings. You can query the event log and then list services, processes. Windows 8, you can list network connections, all kinds of stuff.
Yeah, the ability to use WMI to query network connections is amazing. So in a world where everyone has Windows 8 Plus installed in the enterprise, this will be a beautiful thing. Okay, so I'm going to jump right into a demo here. Now, I've already established connections to my XP and Windows 10 system. So first, let me show you the hard way to do things. I want to query the run key on my Windows 10 system. So what I would do is I would call invoke sim method. I would give it the hive, which is an int32 number, which you'd have to look up on MSDN. Give it the subkey path. We have to specify the class that contains the method to enumerate values, which is std_regprop, the namespace that contains that class, and then we can go ahead and fire this off. Here we go. Okay, so when we get a return value of 0, that indicates success. And so what this did, it just called the enum values method in the std_regprop class as a static WMI method, and it just returned to me the names and the value types of all the values within that key. So the next thing that I would have to do, if I wanted to do this the hard way, was call invoke sim method again, calling the getStringValue method. Now, how do I know to call getStringValue? Because I had to look up in MSDN what type 2 referred to. So type 2 is the reg_sz type. So I'm going to call getStringValue to get the string value. Okay? And so this is just like one of the built-in run keys in a default Win10 installation. So I could investigate this a little bit further, but now let me start to show you the easy way to do this. In SimSweep, I have a function called getCSRegistryValue. Pretty straightforward. Give it your sim session that we established before. Give the hive and the subkey path. And it gives me everything that I need right there in one line. So it breaks out the type value into something that's human readable, and it gives me the hive, the subkey path, the name of the value, and the content of that value, all in a single line. Now let's take this one step further. I started to implement auto runs in pure WMI. So I'm going to give it the logon switch, and many of you are probably familiar with auto runs. I've mapped individual switches for the getCSRegistry auto start function to the tabs that you would see in auto runs. Again, this is all over pure WMI, not running a single script on the host. And I'm running this on Windows XP as well, which doesn't have PowerShell installed on it. Pretty cool. So quickly show you the help of this. And there's not like one-to-one parity just yet of like auto runs functionality to the WMI functionality. It's kind of a pain to get all this, but this is what I have so far. I have all of the following tabs: logon, LSA providers, image hijacks, AppInit, and if you just run it without the switches, then it is implied that you want to return all of the auto runs types. So it's very, very intuitive in my opinion. So cool stuff. I really like it. Jared, you've used it pretty heavily, yeah? All right. Oh, okay. A little more registry stuff. I really like the fact that I can recurse. So get CS registry key. I'll give it my sim session. Let's do this on Windows XP. Again, proving that, well, Windows XP doesn't have PowerShell on it. That's okay. And we have tag completion on some of the switches. Subkey, I don't even need that. Okay, so here's all the root keys in HKLM. Don't clap yet. So I want to show you this awesome switch. Okay, go ahead and clap. Now, what's also really cool is, okay, get registry key is just giving me information on the registry keys. Well, what if I want those values? Well, I can recurse over the keys and then get CS registry value. Boom. I mean, that's pretty intuitive, right? Cool. All right. Now let's move into files. Let's say I wanted to further investigate the executable that was in that run key. So let's do it the hard way. Okay. So to do it the hard way, we're going to do a pretty complicated query on the sim data file class. So here's my query. Basically, we're saying select star from sim data file where drive equals C, path equals this, and we have to escape all paths. File name is that file name, and the extension is exe. Like, that sucks. But it works. Okay? So I can get some file information. Now, by default, those of you who are not familiar with PowerShell, all right. By default, a lot of PowerShell objects are only going to display a certain subset of the properties, but in the sim data file class, there's a lot more properties. So I can just pipe it to some like format list, FL is the alias, star, give me all the properties, and there's a lot of additional properties that you're not seeing by default.
Hi folks, I'm Geek here. Unfortunately, we had another problem with one of the capture devices, so till about the 30-minute, 58-second mark, we have no audio, so sorry for the inconvenience.
that kind of looks at like the registry run keys and a couple other locations for persistence. So yeah, the start menu. Yep. So this would be looking for new registry run keys or new start menu entries. All right, so that was a very basic kind of introduction to WMI and Wmi query language. If you have any extra questions, Ravi, who's a PowerShell MVP, he wrote an ebook that's at this website that goes into a very deep look into WQL. So if you have any questions about that or want to learn more, check out that ebook.
Can you go back?
Yep, sorry.
A little slower. Thank you.
All right, so Uproot, we're kind of going to do an introduction. So it's a WMI-based intrusion detection system. Leverages permanent WMI event subscriptions. You can do things like monitor for general system information, introduction of persistence, lateral movement. It abstracts complexities of the permanent WMI event subscription, so you don't have to understand that there's filters and consumers and what all the arguments to those things are and go to MSDN back and forth through things like a commandlet called new-WMI event filter, which is going to tell you what it needs, or register permanent WMI event. And then right now Uproot has kind of two main built-in mechanisms for reporting events. One is the Windows event log, which is ideal, especially if you have Windows event forwarding, and through an HTTP post method. So you can just have it write directly to Splunk over HTTP through like a REST API. All right, so here's the demo. All right, so the first thing that we're going to do is we're interested in detecting lateral movement. One of the kind of most prolific lateral movement techniques is using the Win32 process classes create method. So you, process call create if you use Wmi. A lot of people use that, so like Cobalt Strike, Empire, all those guys are using that to do lateral movement. What we found is that there is a class called the MSFT WMI provider exec method async event pre. This is actually like a debugging class that allows you to detect when a WMI method is executed. And so in this particular case, we're looking for the object path to be Win32 process and the method name to be create, right? And so every time a WMI method is executed and it's of the Win32 process class and the method's name is create, that's going to trigger. And so we're just going to go ahead and create this. All right, and so you see that we registered this. We're registering it on the Windows 10 VM that we've been kind of playing with. The next thing that we're going to do is we're going to build the NT event log event consumer, which allows us to write an event to the event log upon that lateral movement technique being used. Kind of one of the things that is worth pointing out is the WSH event log provider allows you to write arbitrary data to event ID 8, and so that's why we're using these two right here. WSH just lets you write any strings that you want to that event ID. All right, and so now we've created that consumer. The last thing that we need to do is do that binding and marry these two together. We call that the event subscription, kind of like an umbrella term. And so we're taking the names that we defined up here. So the consumer is called NT process create method. That's arbitrary. And then we're going to marry them together. And so now we have a true WMI event subscription running on that Windows 10 box that's monitoring for the Win32 process create method being called. So now we're going to do kind of like an arbitrary quote-unquote lateral movement or use of that method. This isn't actually going to do lateral movement, but we're going to use that method to spawn a command shell. Just to kind of demonstrate. All right, so the return value is 0. We got a PID for that command shell, so there's now a command shell cmd.exe running on that Windows 10 box. And so now we can leverage SimSweep, Matt's thing that he just talked about, and we can query the event log for source type WSH. All right, so we ran this a couple times to practice, but you kind of get the idea. We have these insertion strings, which are the actual data from the event log. We can see the time that it was run, which looks like it's the older one. Let's see. 10:42:08 a.m., which is the exact time that we're at. And so if we were to, let's see, kind of store that. right, so we have insertion strings, so we could do. All right. And so we get down to the point to where we see the command executed is cmd.exe. So we're not only just notifying you that that lateral movement technique or the create method of 132 process was executed, but we're also telling you what was executed so that you have a little bit more fidelity on that. Yep. So another cool, interesting tie-in to SimSweep is if you were using SimSweep to do like WMI persistence checking, you could also use this to check to make sure that your WMI event subscriptions were registered properly. And so here we're able to see that that WMI event subscription was registered properly. So we have the filter named ext process create method and the consumer named nt process create method. Yep. All right.
Okay, so I've only recently discovered ETW. I think it's a really cool subsystem in Windows for taking like the WMI eventing like one step beyond and using it to further augment the event log for like super low level events that you might be interested in as a responder. So real brief intro, ETW is used traditionally as like a tracing and debugging platform for user mode and kernel mode drivers. So applications can supply events to ETW. These are called providers. And then any application, there's some built-in ones called consumers, can consume these events and establish a session to collect these. The traces are system-wide, so they can be noisy. There's a limited amount of filtering that can be performed, and I will show you that. You can capture these live in real time in memory. You can also capture them to an ETL file as well. So ETW can be really useful for like dynamic malware analysis. In fact, Procmon uses this under the hood in addition to a bunch of extra tools. The only thing is it's not well documented, so you're going to have to do some experimentation yourself. Okay, so a provider is what supplies the events to the consumer that receives those. Some of the really cool providers that are interesting to me is like the Windows kernel trace. So we can get like real-time monitoring of like the registry processes, all in user mode. We don't need a driver for any of this. Windows PowerShell has a great ETW provider. Again, none of it's documented, so you need to experiment. The consumer is what parses these events. So get win event in PowerShell is great for that. There's a bunch of extra tools. A session is what establishes the collection session. It kind of like you basically pick and choose the provider that you want to collect off of. And the controller is what starts that session and allows you to configure it. So some common utilities that you probably use all the time that you may not have realized uses ETW under the hood is the event log itself. NetSH, you can do full packet capture with it, uses ETW. Procmon, Sysmon, Windows Defender uses ETW pretty heavily. You can use Logman to interact with all this stuff. It's pretty low level utility. It's got kind of a learning curve, but I suggest that you invest the time to look into it if you're really interested in this. Okay, so ETW for incident response. Again, there's like two modes. So like real-time tracing in memory, I think would be really good for like real-time alerting for incident response scenarios. And then for ETL captures, what you're capturing on disk, this could be used for like post-mortem analysis or for following up for like remediation actions. You could collect for a while, pull the ETL logs back, and then do your analysis on what was collected. Okay, so the scenario that I want to present for using ETW was I want to detect whenever a .NET assembly or module is loaded in memory. So a while ago I came up with what I thought was a pretty clever WMI event to detect any arbitrary process where PowerShell was being loaded. But then Casey Smith said, well, why don't I just load system.management.automation in memory using the .NET in-memory loader that's built into the .NET class library. So I was like, okay, well that would definitely defeat my WMI event. So I went to ETW, and it turns out there's a great ETW provider and keyword to detect just that. Okay, so attackers like me, I use this technique all the time. I use the system.runtime or system.reflection.assembly static load method to load a .NET byte array in memory. It's great, I love it. So we can capture this with ETW. So sort of the methodology that I used to capture these was I had to look at all the ETW providers that were available. I located one that looked like it might be interesting to me, and I looked at the keywords in that provider. So this is like additional filtering that you can do per provider. I start a trace session with that provider. I run my malicious action, so I go load something in memory using .NET, and then I stop the trace, analyze the results, and if there are interesting events that are populated, then thumbs up. We have a really good ETW provider that we can use for incident response. And then you repeat that whole process again as you're wanting to discover more and more of these ETW providers. So in the interest of time, which we don't have much of, but we are going into lunch, so we're just going to go until we're kicked out here. What you do to query all the providers is called this, logman query providers. A cool thing that you can do is you can specify a PID. So this PID was for a PowerShell process, and it listed out all of the providers that a consumer could tap into for, say, the PowerShell process, or really any like arbitrary .NET process. So I did that, and I discovered this .NET Common Language Runtime provider, and I used logman to start a trace using this provider, and there's a loader keyword. So here's where I'm doing some filtering of just the load event. So anytime an assembly or module is loaded, whether it's on disk or in memory, I'll be able to capture that. So then I go run my malicious action or wait for an actual attacker to do that. I stop my trace, and then I can use a tool like getWinEvent to parse out, in this case, the ETL that I saved to disk to look for those in-memory loads. So this is the on-disk example. I can do this in memory as well, and I don't have time for that demo, but there's a great library out there called TraceEvent, which allows you to capture ETW events in real time using this great .NET library. And so I wrote some PowerShell functionality around that, so you can use PowerShell to do all this analysis in real time. So it's great. I'm still kind of learning as I go. I know there's like a small group within Microsoft who's using this pretty heavily. After the talk, hit me up. If anyone else is using this outside of Microsoft, I'd love to know, and we can discuss like better ways to improve our methodology for using ETW. So, Jared.
All right, so kind of speeding through this. The next phase would be investigation, which is where you've collected all this data, you've analyzed it, you may have found outliers, whatever. Now you need to determine context around those outliers to determine whether they truly are malicious. A couple different ways you can do that is data pivoting, so you can do that through PowerShell Remoting. Go check, what running processes are on that system, persistence locations, network connections. You can build temporal context through some sort of forensic investigation, or you can do historical context through, event logs, proxy logs, so on and so forth. Power forensics, this is how CSI Cyber should actually look. So Power Forensics is a forensics toolkit that's written as a C# DLL or a binary PowerShell module. It allows the inspection of NTFS data structures, MFT, USN journal, etc. It creates an event timeline based on forensic artifacts, so you could look for like file operations in the USN journal, you could look for program execution in the prefetch, you can do user activity in like the user registry hive, so on and so forth. Because PowerShell has been open sourced, I'm working on HFS Plus and ext4 support, which are the two main file systems for Mac OS X and Linux. And then there's a public API that Power Forensics exposes, just like most .NET DLLs. So one of the things that we wanted to do was take ideas from a bad guy, and so Power Forensics, because it's a C# DLL, is not something that you could run remotely very easily unless you have that DLL on every system in the environment. And so we built Power Forensics Portable, which basically answers for those shortcomings. So what we do is we literally dynamically load a Power Forensics C# assembly in memory, which is very similar to what Matt just talked about detecting with ETW. And so that's what this code snippet is here, using that assembly static load method. And then we are able to call Power Forensics public API, which is exposed by that loaded module. And so in this case, we're calling the file record class inside of Power Forensics to enumerate the MFT. So you could parse the MFT that way. We had a demo, but I think we're short on time, so we have the device guard section that Matt's going to cover.
Okay, so who is aware of the Potent Matt's Surface Challenge? Does anyone have a binary that they want me to run on my Surface right now? Anyone? No fun. Matt, you've got something you want me to double click? Do you want to come up? Okay. Oh, it's not an exe? Do you think that you have a legit device guard bypass? Oh, okay. All right. Cool. Well, I mean, yeah, we can certainly meet up afterwards and discuss that. I'm definitely curious to know what you got. So as we've been giving this talk, I've been running device guard on my Surface in what I consider to be very locked down state. So device guard, I've been playing with this a lot. It's great. It definitely has an initial learning curve that you need to get over. But once you've done it enough times and you've gotten into the routine, it's not really that bad. It takes the initial investment to do the initial configuration, but then once you have everything in place, then you're good to go. The only downside is like if you have a really super lockdown configuration and you need to install new software that isn't signed by certificates that are whitelisted in your policy, then it can be a challenge. But there's definitely like a methodology to work around that and test, configure, and redeploy new policies. So device guard is Microsoft's latest whitelisting solution. So a lot of people here probably know that app locker and software restriction policies definitely aren't that great. Like there's a ton of bypasses around them. Like it was certainly a great effort, but this is Microsoft's attempt to take it to the next level. And in addition to just whitelisting user mode binaries and scripts, this also performs whitelisting on kernel mode drivers. It's available in Server 2016 and Windows 10 Enterprise and Education. I wish it was on Pro or even Home for that matter, but it is what it is. It consists of two primary components, code integrity, which consists of user mode code integrity and kernel mode code integrity, and virtualization-based security. These are some like additional hardware-based features that can provide some additional mitigations against kernel mode exploits or device guard specific bypasses. So if you have the hardware to support this, device guard is even better. It's all configurable via the config CI PowerShell module. And basically what you would do is you would take like a gold system, you would scan all the binaries or run all the binaries that you want to execute in your day-to-day operations, and then build a policy based on what a normal user is going to use day-to-day. All right, so device guard versus app locker. App locker is kind of a bolted on feature. If you are an admin, you could just disable it. There are a bunch of protections in device guard if you enable them that attempt to protect against a rogue admin. And if you don't believe me, try to bypass those yourself and give a talk on it. App locker again provided no kernel protections. The policy is applied system-wide. So one of the cool things actually about app locker is that you could apply rules based on user or group. Currently you can't do that in app locker. In device guard, sorry. App locker also has more granular control over modern apps. So app locker can be used to complement device guard. Hopefully the features that device guard lacks that app locker has will eventually be incorporated over into device guard. We'll see.
Hi folks, I'm Geek here. Unfortunately, we seem to have a video freeze here, so we don't have the audio for the rest of the video. My apologies.